All right, hey guys, Miss Davis here. We are in Unit 2, Skill 3, applying vocab to diagrams. So write in this essential question that I have written here. How do we approach and solve problems with vocab words and missing angles? So how do we approach and solve problems with vocab words and missing angles? So go ahead and take a moment to write that down. You can pause the video if you'd like. And we're going to go ahead and start looking at this complex picture that's got a lot going on, and we've got to really dissect it and figure out what it is that they're looking for, what they want us to find, and how are we going to get there. So I'm going to kind of zoom out a little bit here, and let's just read through the problem first on our own. So it says, in the diagram below, DE, this symbol right here, those two lines next to each other mean parallel. So DE is parallel to side BFC. So I'm going to put those little parallel arrows on that line. And BFC, when they use three letters, that just means that it goes through 3 points like that. BFC on the bottom. The measure of angle A is 82, which is labeled on the diagram. The measure of angle C is 26, which is already measured on the diagram. And DF bisects angle BDE, which means that it cuts it in half. Okay, so it actually creates two congruent angles. So BF or DF is bisecting angle BDE. Okay, so our problem down here says determine the measure of angle DFB. So if I look at my diagram, I'm going to follow from D. I'm going to highlight the angle that they want us to find. So I'm starting with angle D, and I'm just kind of adjusting my colors here. So I've got to go from D to F to B. So here to there to there. So that angle inside there is where I'm going to put an X. Okay, so that's our angle that we want to find eventually, and we need to figure out how to get there. So the first thing that I always look for in a picture with triangles is, do I have a triangle where I know 2 out of the 3 angles in the picture? And in this case, I can look at the smaller triangle DBF. I don't know any of those angles yet. I can look at the top triangle ADE up in the top. I only know 1 out of the 2 angles. And then there's like this trapezoid that's down to the right, which we only know 1 of those angles. But what I want you to take a step back and look at is this bigger triangle ABC. So if I look at triangle A to B, well, let's kind of do that in a darker, A to B, this big green triangle on the outside here, that triangle we actually know 2 out of the 3 angles. So if I go and I can figure this angle down here out, right down there. So I've got that the measure of angle A, if I add the measure of angle B plus the measure of angle C, the 3 angles of a triangle should add up to 180 degrees. So our first kind of skill and concept we're going to use is that the 3 angles of a triangle add up to 180 degrees. So my angle A is 82. I'm going to plug in 82 degrees there. Plus my angle B is what we don't know yet. So I'm going to go ahead and just leave it as angle B. And then plus angle C, which is down here, is angle 26 degrees, equals 180. Okay, so between these 3 angles, I got 82 plus 26 is 108. So 108 plus angle B is equal to 180 degrees. Subtract your 108 from both sides, and we get angle B is equal to 72 degrees. Okay, so I'm going to come over to my diagram and I'm going to plug in a 72 degree angle right there. So now I've got my third angle of that bigger triangle. So now what I need to look at and use this idea after I see that there are no more triangles that I know 2 out of the 3 angles with, I need to look at this idea of being parallel, of having these parallel lines. So if I've got parallel lines, then I'm going to need to look for some kind of angles that I can help fill in some other angles with. Okay, so I actually see a pair of corresponding angles, so I'm going to go ahead and highlight using my highlighter the parallel lines first. So I'm going to do that in purple. So I've got a parallel line at DE, and it is parallel to BFC down there at the bottom. Now if I highlight the transversal that cuts through them, so the transversal I'm talking about here in this case is going to be ADB, where those purple lines meet up are actually going to be a pair of angles that are congruent. So the angles in here, right here and right here, so that 72-degree angle and this red angle up top are actually called corresponding angles because they're in matching locations where a transversal meets a parallel line. So where that purple angle turns by D and where the purple angle turns by B, those are actually corresponding angles. So I can go ahead and also label this angle up here as 72 degrees. So off to the side, I'm going to say that corresponding angles are congruent. Okay, and I'm going to kind of just draw the picture that you might be a little bit more familiar with was the two parallel lines cut by a transversal. And whenever there are angles that form in matching locations like here and here, those are called corresponding angles. Or if I had two angles, one that met here and here, those would be corresponding angles. So I'm going to add a little justification down here at the bottom as well, because every time you put a new angle on your picture, you want to have a definition or a reasoning or some set of work that matches what you did to explain it. So the angle that I just marked was angle ADE. So the measure of angle ADE is equal to 72 degrees because, and there's that justification, we have to justify, so we have to explain, is equal to 72 because corresponding angles are congruent when lines are parallel. Okay. Okay, so now we need to continue and we need to look at how are we still, our goal is to get that orange angle X there, BFD. So how are we going to get that angle there? Well, we need to look at this pair, this actually three pair of angles that lie on this line right there. So we know something about side BF is bisecting and cutting in half angle BDE. So this angle right here is actually congruent to this angle right there. So there's two congruent angles in here. There's this angle and this angle are being cut in half by that line DF. So if I know that three angles on a line should all add up to 180 degrees, then these three angles right here where I'm outlining in red, they should all add up to 180 degrees, and the two ones that are unknown should be equal to each other because of the bisector. So I'm going to go ahead and start with number 3, and in order to, if I know that that top angle out of the three of them is 72, then I'm going to do 180 minus 72 is equal to 108 degrees. And I know this because angles on a line equal 180 degrees. Then I know that 108 degrees that's left, I need to use and split up between these two angles here and here. So my second step is to do 108 divided by 2 is going to give me 54 degrees because a bisector divides an angle in half. So once I have done that step, I've got 54 degrees that I can come up here and label as this angle here, 54, and this angle in here is 54 degrees. Okay, so now all that I have left and all that I really need now is this smaller triangle, DBF. So I'm going to outline that in green, DBF, and let's redraw it down here for step 4. So now I've got a triangle, DBF, and I know that the top angle is 54 degrees. The left angle at the bottom is 72, and I need to find x there. So now I can use the idea that the three angles of a triangle add up to 180 degrees. So 54 plus 72 plus x is equal to 180 degrees. So then from here, I can go ahead and solve. 54 plus 72 is 126 plus x equals 180. Subtract 126, subtract 126, and get x is equal to 54 degrees. Okay, so that means x is equal to 54 degrees, but let's just go up there and kind of restate our answer. So our final answer should be the measure of that angle that it asked for. So the measure of angle DFB is equal to 54 degrees. Okay, and this last step in here, if we wanted to add our reasoning, is that the angles in a triangle equal 180 degrees. Okay, all right, so that was a very beefy one. We had to use parallel lines, we had to use angles on a line, we had to use a bisector, so there's a lot of stuff going on. Let's go ahead and take a look at another one on the back side. Okay, so we have another one of these missing angle pictures, and we've got some vocab we have to unpack here. So in the diagram below of triangle M and O, angle M and O are bisected by MS and OR. So if these angles are being bisected, then that means that they're being cut in half into two congruent other angles by MS, and if you look, MS goes directly through this angle M here, and OR goes directly through the middle of angle O, which is the other angle that's been bisected. Okay, so just keep that in mind, that those angles are being cut in half. So if you know the whole angle O is 100, then they're each 50-50. But we don't know that yet. So respectively, segments MS and OR intersect at T, and the measure of angle N is 40 degrees, which is already labeled on our picture. Okay, so as of right now, we can't label anything else on our picture, but if we read further, it says if the measure of angle TMR is equal to 28, so we have to label this, okay, on our diagram. So TMR is this angle right here, is a 28 degree angle. Okay, so in there, if that's a 28 degree angle, then we know that that angle M has been bisected. So first step, we know that, so basically with these pictures, you're just going to start filling in angles, and it's like a big puzzle. Start filling in all the angles that you can until you find the one that you need. So first of all, if we know that that angle has been bisected by MS is the bisector, then that means that this angle over here is also 28 degrees. Because angle M as a whole was cut in half. So step 1 is just to recognize that this was an angle bisector, or the angle was bisected. Okay, so right inside there. Okay, so step number 2, let's look at what we're looking for. So the measure of angle OTS. So angle O to T to S is this angle right inside there. Okay, so we don't see anything else inside that triangle. Like we don't have 3 angles or 2 angles that we can subtract from 180 in that triangle OTS to get that angle X. So then we need to keep looking and seeing if we can find other angles in our bigger picture. So if I look at my bigger picture, I can see, do you guys see the big triangle OMN? So if I look at triangle OMN, I'm going to highlight it in green. OMN, this bigger triangle here, I can use this information now, this triangle. I know 2 out of the 3 angles. So I know that together, 28 plus 28 makes 56 degrees between these 2 angles when we add them together. So if I add 56, so step 2, if I add 56 degrees plus the 40 degrees in the bigger, or the bottom right here, plus this angle O up at the top is going to be the third angle of that big green triangle. So I'll put angle O. They should all add up to 180 degrees. So when I combine those 2 angles, I get 96 plus angle O is equal to 180 degrees. So subtract 96, and we get that the measure of angle O is equal to 84 degrees. So this whole angle O is 84 degrees, but what I want to do is look at when I split that up over those 2 smaller angles, because that OR line was, remember, it was the bisector, so it's cutting that angle in half. So step 3 is going to be take 84, divide it by 2, and we're going to get 42 degrees is going to go in each one of these little angles in there. So 42 degrees there, 42 degrees there. Okay, so can I yet use anything that I have to find the measure of angle X, or OTS is what we're finding. So we also want to pay attention to the fact that across from it, right here and right here, these angles form at 2 intersecting lines, and if they're across from each other, they're called vertical angles. So let's see if we can get there yet. Do we have a way that we can find its vertical angle? I don't see how yet. So at this point, we're going to look for another triangle within this crazy picture that we have 2 out of the 3 angles. So if I look at, I actually see one. If I identify this triangle right here, O to R to N, back up to O. Do you see how that triangle right there, I know that this angle at the top is 42, this one down here is 40. So what I can actually do now is step 4, I can find this angle down here. So I can do 180 minus 42 minus 40 to give me that angle. We can name it ORN. ORN. Okay, so 180 minus 42 minus 40 is 98 degrees. So 98 degrees is the measure of angle ORN. So I can come up here and put a 98 degrees here. Okay, well, how does that help me here? Well, it's getting me closer to my, see the red angles in the middle? Those are, again, going to be equal vertical angles. So I'm almost inside of this triangle. And if I look for this angle right here, 98 degrees, is directly next to that angle. And those are angles on a line. So step 5, if I want that other angle on the other side of 98 degrees, I'll just do 180 minus 98. And that gives me 82 degrees. So over here is 82 degrees. Okay, so now I'm going to use another color highlighter and highlight the triangle that we really do need in this picture to determine, so I'll do it in purple here, that vertical red angle. So if I highlight this triangle here, do you see how I know 2 out of those 3 angles? So my goal is to find the red angle. So my last step here, number 6, is I'm going to take 180 degrees in a triangle, subtract off that 28 degree angle in the bottom left, minus the 82 degree angle on the right. And when I subtract all 3 of them, all 2 of them, I get 70 degrees. So that means that inside of there, that little angle is a 70 degree angle. And right across from it then is also going to be 70 degrees. So then our step number 7 is going to be that angle OTS is equal to 70 degrees because of those vertical angles. Okay, so our answer after all that work is number 4, 70 degrees. Okay, now our last example here, example 3, is got some more vocab in it, so let's read through it. In the diagram below of isosceles triangle, so an isosceles triangle has two congruent angles and two congruent sides. Triangle ABC, where AB is congruent to CD, very important that we label this on our diagram. And angle bisectors AD, BF, and CE are drawn. So now we've got angle bisectors that create two congruent angles. So when we go to label those congruent sides on our picture, I know that from A to B is, I'm going to put a tick mark on AB, so drawing these brackets because they go past a point. So see how it goes AEB, I'm going to skip over E and show that that is equal to C to B, which means that if those are the two congruent sides on an isosceles triangle, then these are the two congruent base angles because this would then be the base. Okay, so what we really have here, if I split this or redraw this, is I've got triangle A with B at the top, C all the way at the left, or sorry, the right, and I've got two congruent base angles with my two congruent legs. Okay, and so they also tell me that I've got angle bisectors, AD, BF, and CE, which means that all three of those lines cut these angles in half. So let's see, go all the way down to the bottom. We have no degrees yet, so we can't label anything, but it says if the measure of angle BAC is 50. So I'm going to go from B to A to C, which means that this whole angle here is 50 degrees, which means actually that this is 25 and this is 25. Okay, so and if this red angle on the left is 50, then this one on the right is 50 because that's the equal base angle. So that's 25 and that's 25. Okay, so then what do they want us to find? Find the measure of angle AXC. So AXC is going to be, I'm going to do this in a different color. AXC is this angle right here at the top. So what I need to do is take a step back. AXC is not an angle of the big triangle ABC, but we are going to use the idea that those were bisectors and those angles on the bottom there. And I'm going to outline that kind of short, like stocky, short and stumpy triangle in there, which is a triangle AXC. So this triangle right here is what we're actually going to use now to figure out this top angle in here. So if I redraw it off to the side, and this is triangle AXC, I know that this bottom angle is actually 25 degrees. This is 25, and we need to find this angle up there. And we know those are congruent, and these are those base angles. Okay, so now our last steps are just to take 180 degrees in a triangle and subtract off your two base angles. So when I do that, I get 180 minus 50 is 130 degrees. So let's just kind of rewrite our answer there. The measure of angle AXC is equal to 130 degrees. Okay, so what I want you to do now is take a minute, take a step back. I know there's a lot of writing and a lot of stuff going on, but come up with some steps or maybe a summary at what you could do to get yourself started on these tricky diagram pictures before you do any practice.